Okay, so this video is for the second part of R4. You can see here I'm referring to it as R4.2. Again, that is not a section in our textbook. Our textbook just has R4 in it. And so you will just, for these problems, you will look at the, go to the end of section R4 and look for those problems. I'm just indicating this is my notation that this is the second half, second part of the factoring section, R4. Okay, so we're continuing with our factoring. Now, we're using the same ideas that we learned in the last lesson for factoring, factoring trinomials, differences of squares, and those kinds of things. But they look a little different than we did before. So for example, look at this problem here. Trying to factor this. That doesn't look like anything we've ever done before. But if we do a really simple substitution, notice this binomial a plus 1 is being squared, and then there's an a plus 1 here. If we do a little substitution, take out a plus 1 and substitute it in a u. So we have 8u squared. So we took this out and replace it with a u. Take this out and replace it with a u. Then we have a trinomial that we might be able to factor. And so let's do that by trial and error. So we're going to, it's going to be a u and a u, right? U and a u, but it might have some coefficients, right? So it could be 8u and u, or 4u and 2u. I'm going to go with 4u and 2u and see if that works. So 4u and 2u. And of course, if I can't get that to work, I'll go back and use 8u and u. All right, so 15, that could be 15 and 1, but probably going to be 5 and 3. All right, now, neither of those have common factors, so that doesn't help us eliminate it. If we did 5 and 3, let's see, that's going to be 20, and that's going to be 6. Oh, the negative here tells me I know it's a difference, so that's going to help. I'm going to want to do that one, right? If I did a 3 and a 5, then that would be 12 and 10, and that difference wouldn't be correct. So we want to stay with the 4 times the 5, 4u times the 5, that will give us 20u, and then 3 times the 2u, that's 6u, and that has a difference of 14. So 20 minus 6 is 14. So the result of the 2 is negative, so I need the bigger one to be negative. 20u should be negative, and 6u should be positive. Okay, so I've done that. And now let's unsubstitute. So let's put so essentially what we did to get from here to here is that we let u equal a plus 1, right? And so now we're going to unsubstitute. We're going to take out the u, so we have 4 times a plus 1 plus 3. Let's put that in a bracket, square bracket, and then we have 2, and that's a plus 1 minus 5, and we'll end that with a bracket. Okay? Now, the thing is, we should simplify this in here now, right? I mean, I know we're factoring, but we could, this is going to be 4a and a 4 plus that 3, so that's going to be 4a plus 7, 4a plus 7, and then this will be 2a and a 2 minus a 5, so that's going to be 2a minus a 3. All right, so yeah, we don't want to simplify, we don't want to FOIL this back together because we're factoring, so but we will kind of do, if we FOILed all that out, we would end up more with this thing, but that's probably the best answer here. Okay? All right, let's look at A then. So for A, let's do a substitution. So it's kind of what we do mathematics we say let, and then we're going to say what we're substituting. So let u, and u is kind of the universal variable we use when we do substitution. You'll see that later in next year's math classes. So we'll do let u substitute in for 2a minus 1. All right, so let's rewrite what we have. We have 10 u squared minus 19 u minus 15, and that's what we want to factor. All right, so let's see about factoring that. There's no common factors, so we're not taking out a GCF. We have 10 u squared, so let's assume it's going to be 5u and 2u, and then 15 is probably going to be 5 and 3, but I can't put the 5 here, so I'm going to try a 5 and a 3, and I'm going to see if this works. If it doesn't, then I'm going to go back and maybe try a 10u and a u, maybe try 15 and 1. Let's see if this works. So that's 25, and that's 6. That negative says the signs are different, so we want a difference that's 19. That seems to work. Okay? So which one should be which? The 25 I want to be negative, and the 6 I want to be positive. So that will give us the center term of negative 19u. All right, so now let's undo that substitution. And so we get 5 and then u, which is 2a minus 1, plus 3. And here we have 2u, which is 2a minus 1, minus 5. And I'm just using square brackets because we have inner parentheses. And now we distribute the 5. So we get 10a, we'll get negative 5 plus 3, so that's going to be 10a minus 2. And then we get, what, 4a, that's going to be 2, negative 2, negative 5, that's negative 7. All right, now this is almost a perfect answer, except in one of my binomials, I end up with a common factor. So we want to factor a 2 out of that. That's 5a minus 1. And this one we leave like it is. Okay, so that is our answer for that one. All right, next one. So we have a binomial cube plus 8. That's going to be a sum of cubes. So let's do a substitution. Let u equal 3b plus 2. All right, so then we get u cubed plus 8. And that's going to be a binomial times a trinomial. The same, opposite, always positive. U and 2, u squared, 2u, and 4. All right, now we want to plug, unsubstitute, plug the 3b plus 2 back in. So that's going to be 2b plus 2 plus 2. Let's hang on, I'm being a little sloppy here. Let's leave this in parentheses because that was what they're substitute. Oh, sorry, 3b plus 2 plus 2, and then we have 3b plus 2 quantity squared minus 2 times, I'm running out of space here, 3b plus 2 plus 4. Okay, so here let's simplify this. This is going to be 3b plus 4 out in front. And then we need to FOIL this out. Let's see. Let's put that in square brackets still. That's going to be 9b squared twice the product. The product is 6b. That's going to be 12b, and then plus 4. and then distribute. That's negative 6b minus 4, and then plus 4. Okay. And then let's see, we have this 4 and this 4 will cancel. We can combine the b's. So let's see, we have 3b plus 4 out in front. We have 9b squared plus 6b, and then I think a plus 4. Okay. All right, and then, you know, technically, I guess we should see if this factors. I mean, this is a perfect square. This is a perfect square. It's not a perfect square trinomial, but I'm going to assume that doesn't factor, but I'm about 90% sure this doesn't factor. It might factor, but probably doesn't. Most of the time, the resulting trinomial is not factorable, but with these special cases, it might be. Let's just try. We have probably 3b and 3b. It's not gonna. It could be like 4 and 1. No, that doesn't work. So yeah, I don't see that that's going to be factorable. Okay. All right. Let's go on to the next one. Now, in this case, the variables isn't a binomial. It's a monomial z, but it's to the wrong power, right? We've been factoring degree 2's, and so this would be a square, and this will be just a z. So, but it has the same form. If we let u equal z squared, which was the center term, then the center term is negative 13u, and this is still minus 5. What will this be? This will be 6z squared. Sorry, u squared. All right, so if I put, for u, I put in a z squared, it's z squared squared, which is z to the 4th. All right, and so now we can see this is much easier to factor. Some people could factor this with, just as it is. That's fine. If you can do that, great. Let me try to do a dividing line between these two. So I'll shift over a little bit. So let's try factoring that. All right, the signs are different. I know that. I'm going to leave the signs for last. Let's go with 3u and 2u and see if that works. If not, I'll go back to 6u and u. 5 and 1 or 1 and 5. If I put the signs are different, so if I put the 5 here and the 1 here, then that means that difference of the outer and the inner is not going to be 13. So I want the 5 out here to multiply by the 3. So 5, that's 15u, and then the 1's here. So 15u minus 2u, that's 13u, so that's right. But I want the bigger product to be negative, because there's a negative there. So we'll do negative and positive. All right, now we'll unsubstitute. So instead of u, I'll put in z squared. So 3z squared plus 1 and 2z squared minus 5. And so, if you can go from here without doing a substitution down to here, down to this step here, more power to you. If you feel like, so long as this variable squared is over here, right, this is the square of this variable, then it's in a quadratic form. And so you could kind of say, oh, well, this is going to be z squared, this is going to be z squared. How else would I get z to the 4th, right? So if you can jump over that substitution in this simple case, feel free to do that. Okay, and so like here, you might try that. There's no GCF. Let's try doing it directly instead of doing the substitution. If you want to do the substitution, it would be what? Let u equal, it's always this middle term, x cubed, and then u squared would be x to the 6th, right? But let's try this. These variables are always going to be the same, so we're going to be x cubed and x cubed. The product of x cubed and x cubed is x to the 6th. Which, it has to be the center term, right? The variable in that center term. All right, so for, maybe it'll be 2 and 2. We'll try that first. If that doesn't work, then we'll go back and try the 4 and 1. And then, so let's put that in 2 and 2. And then 21, well, that's going to be 7 and 3. We don't have to worry about common factors here. Let's see if this works. We have 14 x cubed, and we have 6x cubed. The negative here tells me I want a difference. So that sounds right. 14x cubed minus 6x cubed is 8x cubed. So that's good. The positive tells me that this has to be positive. This has to be negative. So you can go directly to that if you feel comfortable. Otherwise, use your substitution. Write it as a true quadratic, a true degree 2 polynomial, trinomial, and then you can factor it as well. All right, this one, let's do, if you feel comfortable, it's something squared minus something squared, right? So that's a difference of squares. If you need to do a substitution, that's fine. Say let u equal 4c minus 9. All right, but if you can think about it as just like this is something squared minus something that's squared. So it's the square root of the first, which is 4c minus 9 is the square root of this first thing, plus 5. And then square root of the first, 4c minus 9 minus 5. All right, and then we would just want to simplify inside here. So that's 4c, minus 4, and 4c, minus 14. All right, now this one's unusual. This has a GCF, and this has a GCF. So we'll take a 4 out of the first, so c minus 1, and we'll take a 2 out of the second, so that's 2c minus 7. But we don't leave these two things, it's like essentially 4 different things multiplied together, but we take these two out together out in front. So it's 8c minus 1 times 2c minus 7 is the best answer there. Okay? All right, let's try the next one. For this one, whenever it's binomials raised, I'm going to do the whole substitution. So let u equal 3x minus 2. All right, so that gives me u squared plus u minus 30. Again, if you can do this without, but this one's a little harder to do without the substitution. All right, so we should be able to factor that. And that's what? U and u, product of 30, and has a difference of 1. That sounds like 6 and 5. We want the 6 to be positive because this is plus and a minus. All right, and so let's unsubstitute. We have 3x minus 2 minus 5, and 3x minus 2 plus 6. All right, and then we just want to simplify inside. So 3x minus 7, and that will be 3x plus 4. Okay. Okay, yeah, I think that's right. I'm looking at my answer key, and I think I wrote it wrong last time when I was doing that. 3, yeah. So my answer key is wrong. This is correct. Okay. All right. So again, the homework for the next class is listed here on the bottom of your notes. Again, the evens, and then these are all. So the evens and the odds, what we mean by that. And again, look at the end of section R4 and do these problems. All right, do next class.